Good morning viewers. Welcome to our IVJ channel. In this video we discuss about the couple acting on an electric dipole placed in an uniform electric field. So derive the equation derive the equation for the couple acting on an electric dipole placed in an uniform electric field. So here what we have to find a couple acting on an electric dipole when placed in uniform electric field. So first of all, what is electric dipole? Definition of electric dipole. So what is the definition of electric dipole? Two charges are there. So the two charges are equal in magnitude but opposite in direction. So one is plus q and the one is minus q. We are considering two charges, equal charges but opposite. So opposite charges, equal magnitude, opposite charges are placed at a distance of 2a. So two equal and opposite charges are placed at a distance of 2a is called electric dipole. An electric dipole. This is the definition of electric dipole. Now draw uniform. See, what is electric dipole? Here a q charge is there. That charge is q. Another charge, that also q. So two charges equal in magnitude. One is plus q, another one is minus q. These two equal charges which are in magnitudes are equal, but the distance between them equal to 2a. Then this is called electric dipole. Now this electric dipole is placed in an uniform electric field. Now, so uniform electric field. So this is the electric line of force. This is 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 electric line of force. So all these are electric lines of force. Electric lines of force. Electric lines of forces. Electric line of force 1, 2, 3, 4, 5, 6. So this is electric line of force. Second electric line of force. So total electric field you can write. So electric field. But how much uniform? So what is this that field? Uniform electric field. So this is a uniform electric field. Now what we are doing? We are taking a dipole. Dipole means two equal charges but magnitudes are equal but opposite direction are placed in uniform electric field. Then what happens? Suppose this position is A. The position of plus Q is A. And suppose the position of minus Q is B. Now, this is making an angle of, this electric dipole is making an angle of theta. Now, this is electric field. Now, let it be this one. Let it be this one. Uniform here. Here. Now, what is the angle made by the electric dipole with the electric field? Now take the angle between these two. Let theta be the angle between electric dipole and electric field. Uniform electric field. Now here, let it be here. Let it be here. Plus Q. Okay. Now, see, draw a perpendicular from Q. This is the perpendicular, and extend this one up to C. So let this be C. Now, what is here A? AB is electric dipole. AC is perpendicular. So here BC ఉంది, that is magnetic line of force. నేను ఏం చేశానంటే ఎలక్ట్రిక్ డైపోల్ తీసుకున్నా. ఎలక్ట్రిక్ డైపోల్ అంటే ఏంటంటే 2 చార్జెస్ ఉన్నాయి. ఆ 2 చార్జెస్ యొక్క మ్యాగ్నిట్యూడ్ సమానంగా ఉంటుంది. కానీ ఒకటి ప్లస్ క్యూ అయితే ఇంకోటి మైనస్ క్యూ, ఆపోజిట్ చార్జెస్. ప్లస్ క్యూ మైనస్ క్యూ 2 చార్జెస్ ఉన్నాయి. ఆ రెండింటి మధ్య రెండు సమానమైన మ్యాగ్నిట్యూడ్ కలిగిన చార్జెస్. సేమ్ సపోజ్ 1 కూలంబ్ అయితే ఇది 1 కూలంబ్, ఇది 2 కూలంబ్స్ అయితే ఇది 2 కూలంబ్స్, ఒకటి ప్లస్ ఇంకోటి మైనస్. అయితే ఏం చేసాను, వాటి మధ్య డిస్టెన్స్ 2a అయినట్లయితే ఆ డైపోల్ని ఏమంటామంటే ఎలక్ట్రిక్ డైపోల్ అంటాం. దీన్ని ఏం చేసిన మ్యాగ్నెటిక్ ఫీల్డ్లో ఉంచా. మ్యాగ్నెటిక్ ఫీల్డ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఎలక్ట్రిక్ ఫీల్డ్లో ఉంచా. దేనిలో ఉంచా? యూనిఫామ్ ఎలక్ట్రిక్ ఫీల్డ్లో ఉంచా. యూనిఫామ్ ఎలక్ట్రిక్ ఫీల్డ్లో ఉంచినప్పుడు ఈ ఎలక్ట్రిక్ డైపోల్ ఏం చేస్తుంది అంటే సమ్ యాంగిల్ చేస్తుంది. ఎంత యాంగిల్ చేస్తుంది? θ యాంగిల్ చేస్తుంది. దేనితో? ఎలక్ట్రిక్ ఫీల్డ్, ఎలక్ట్రిక్ లైన్ ఆఫ్ ఫోర్స్ తోటి. సో నేనేం చేస్తున్నా అంటే ప్లస్ ఏ దగ్గర నుంచి, అంటే ప్లస్ క్యూ చార్జ్ దగ్గర నుంచి ఎలక్ట్రిక్ లైన్ ఆఫ్ ఫోర్స్ ఉంది కదా ఇక్కడ 6th లైన్, దాని మీదకి ఏం చేస్తే పర్పెండిక్యులర్ డ్రా చేశా. సో పర్పెండిక్యులర్ డ్రా చేశా. తర్వాత ఈ లైన్ ఆఫ్ ఫోర్స్ని బీసీ కంటిన్యూ చేశాను. సో ఇక్కడ ఏం ఫామ్ అయింది? రైట్ యాంగిల్ ట్రయాంగిల్ ఫామ్ అయింది. సో రైట్ యాంగిల్ ట్రయాంగిల్ ఏబిసి ఈజ్ ఫార్మ్డ్ నౌ. ఓకేనా? ఫ్రమ్ దిస్ so here some force acts on A and B. Here some force acts on A and B. So this side magnetic line of force acts. So this side force acts. What is that force called? F. And this side on this minus charge, this side force acts. But these two forces are equal. So what is the force equation in this case? F equal to EQ. In this F equal to EQ. Force equal to EQ. What is E? Here F means force. E means intensity of electric field. Electric field intensity or intensity of electric field. Intensity of electric field intensity. Q means charge. So from the definition of intensity of electric field, already we know E equal to F by Q. E equal to F by Q, we know. So here, what is intensity of electric field? The force acts on unit charge. So force per unit charge. So F by Q gives intensity of electric field E equal to F by Q. From this, what we can write? F equal to EQ. So I am writing F equal to EQ. Here F equal to EQ. But here F equal to plus EQ. Here F equal to minus EQ. Since this is plus Q, this is minus Q. Okay now. So since forces are equal but acting in opposite direction, automatically this dipole rotates in clockwise direction. Means couple formed. So due to these two forces, let it be F1, let it be F2, no problem. So these two, since F1, due to these two forces F1 and F2, the electric dipole rotates in clockwise direction. Means couple formed. Since let it be F1, let it be F2. Since F1 equal to F2 and acts in opposite direction, it rotates in clockwise direction like this. The dipole rotates in clockwise direction. So here that force is called torque. If a force acts on a body to rotate in clockwise or anti-clockwise direction, that force is called torque. Now, so torque equal to tau. But these two equal. What is the definition of couple? Couple means if two forces acts at the 2 points in opposite direction, then automatically that body or that dipole, whatever it may be, it rotates in clockwise or anti-clockwise. So we can say it as the two equal and opposite forces acting on the same body or at the on the same body at the two ends of your body, then it produces a couple. Example, whenever a driver is rotating this steering, so how many forces are acting at? Two forces. One is by applying force on at the one end of the by the right hand side in clockwise direction, and other force acts at the other end of the steering with the left hand side, but in the same direction, opposite direction. See, one is downward direction, one other force is acting, applying in upward direction, downward direction, upward direction. But two forces are, see here, let it be. This force acts this one, and this force acts this one. So two forces are acting. This is a force. This is also force. The steering rotates. Two equal forces acts in opposite direction on the same body at the two ends of a body. Then it produces couple. So the force is nothing but torque. So the force acts on a body to rotate the body is nothing but torque. We studied about already. We know about the torque in the previous classes. That means in intermediate first year. So torque produced. So the torque produced is nothing but couple. So torque produced equal to couple. Okay, about this one, copy this one. I will give the derivation equation 8. Copy this one. Therefore, here uniform electric field, this is a dipole. Now the draw perpendicular from here to here. So this is B, let it be. This is B, A, and this is C, perpendicular. This is theta. Now torque equal to, this is length equal to 2A. So here length of dipole equal to length of dipole AB equal to 2A. Now AC is perpendicular. AC equal to perpendicular drawn from drawn from A onto the magnetic line of force. Magnetic line of force. Now, so here theta is the angle between AB and BC. Theta is the angle between AB and BC or magnetic line of force. Now ABC is a triangle form. Now due to torque produced, torque applied or torque acts, torque applied tau equal to couple acts on the dipole. So torque tau equal to couple here force into perpendicular distance. Force into perpendicular distance. Now torque tau equal to force means F into perpendicular distance means what? To AC. Now, but F equal to EQ, already we discussed this F equal to EQ, we know. So F equal to EQ into AC means from the triangle what we can write to AC? From right angle triangle AC, ABC, sin theta equal to AC by opposite by hypotenuse, AC by 2A, AC by AB means AC by 2A. From this AC equal to what we can write? 2A sin theta. So right here AC means 2A sin theta. So you can write here E into, write Q into 2A into sin theta. Now E into 2AQ. Since P equal to 2AQ, C means P means moment of electric dipole, equal to P equal to 2AQ. So I am writing 2AQ means P into sin theta. So E bar cross P bar, here EP sin theta, E intensity of electric field, vector quantity, P momentum, vector quantity, electric dipole momentum, vector quantity sin theta. So if what is the relation, we know A bar cross B bar equal to AB sin theta. This relation we know. A bar is a vector, B bar is a vector, then if the cross product of A bar and B bar equal to AB sin theta. So E is a intensity of electric field, vector P momentum of electric dipole, vector sin theta. What we can write? E bar cross P bar. So what is left side is tau. So torque is a vector E bar cross P bar. So intensity of electric field cross P bar, momentum electric dipole. So torque tau bar equal to E bar cross P bar. So this is about the torque produced on uniform electric field. Okay, copy this one. Write this one. Otherwise, you can write here Q into 2A is there, then you can interchange this one as, because P vector notation cannot obey commutative law. So you can write 2AQ into E sin theta. So you can write as tau bar equal to 2AQ means P bar cross E bar. So here tau bar equal to P bar cross E bar. This obeys, this is this torque obeys right hand rule. Torque obeys right hand. Torque equal to V bar cross E bar. Okay, that's it. Okay, this is about the dipole torque equation of the couple acting on an electric dipole in magnet in an uniform electric field. Okay, copy this one and like the video, share the video and subscribe our IBJ channel. Okay, carry on. Copy this.